Hello students, welcome back to my channel. In today's session, we will be learning the algorithm computing the prime factors of an integer. So let us go ahead and see the problem statement of this particular algorithm. The problem statement tells us that every integer can be expressed as a product of prime numbers. So design an algorithm to compute all the prime factors of an integer. So which means we know that any number, for example, if I have to take 20, 20 can be expressed as 10 into 2, or it can be expressed as 5 into 4, or it can be expressed in many ways. So the problem statement tells me that whatever the factors I'm trying to put here, which I'm going to multiply and get the result, has to be prime numbers. So the numbers, whatever we use here, has to be prime numbers. So let us see the definition of prime factorization. So the process of writing a number as a product of prime numbers is prime factorization. So that is what I was talking about. So how can we generate that? For example, in a simple way, if I have to using a division method. So 288, let us start with 2. I will divide it by 2 because of course 2 is the smallest prime number. So let me start with the smallest prime number. So I know that it divides 144 times. Next, can I further divide it by 2 itself? Yes, I can. So I will divide it by 2. So 72. All right. Again, since it is a even number, I know that I can further divide it by 2. So I will get 36. Once again, I can divide it by 2. I will get 18. Then again 2. 9s are 18. Now, when I come here, I know that I won't be able to divide it by 2. Next, we have to check the next prime number, which is the next prime number. Of course, it is 3. So 3 3s are 9. And once again, I can divide 3 1s are 3. And we will not take 1, but we can end it here, which means I can easily write 288 as 2 into 2 into 2 into 2 into 2 into 3 into 3, which is nothing but 2 to the power 5 into 3 square. So this is the prime factorization of 288. So that is what is this algorithm is asking us to create an algorithm in order to represent any given number in the form of multiples of prime numbers. So it can be 2, 3, 5, 7, 11, 13, any of the prime numbers you can use, but it has to be multiples of prime numbers. All right. So if I can give you few examples like 20, you can write it as 20 can be written as 2 into 2 into 5. So this is once again a prime factorization of 20. So similarly, you can take different numbers and you can try. So what is the method to do in order to generate an algorithm for this? So what is the methodology we can use? So from the example, what we have seen is, first, it is always suggested to start with the smallest prime number. So use this until you are not able to use. Okay, that means to say divide by 2 until the number is not divisible by 2. So let us start. So this is 54. Once again, 2, 2s are 4, 7, 27. Okay, so 27 is not an even number. Hence, we can stop dividing it by 2. So which is the next number? So usually we can take the next number as the next number is always 3. 3 is the next prime. So of course 3 divides 27 9 times. 3 3s are 9, and then we can stop here. So if you see the pattern, usually you can go from 2, 3, 5, 7 and up till the square root of this particular number you can go. All right. So because it is division, usually we have already seen in the previous session. So why do we go up till only the square root? Is because we assume that the multiplication. So for example, if I'm taking 6, 3 into 2, 3 into 2 gives us 6. Similarly, 2 into 3 gives us 6. I need not go beyond this. That is beyond 3. I need not go. Half of 6. I need not go beyond that because already we will get all the multiples. Then after that, whatever it is going to be the repetition. Hence, we will loop up to root n, and then initially until the number is odd, we are going to divide it by 2 because 2 is a prime number. Once we are done with 2, then we will initialize the value to 3, and then we can go on increasing the value, and then we will find the prime factors. Okay, so let us go ahead and see the algorithm. So this is the algorithm. First, we will start declare variables n and I. So I'm going to declare the variable n and I, where n is the number. Okay, n is going to be the value. For example, let me take 36, and the value of I is of course going to be 2, because initially we are going to start with the 2, which is the smallest number. Okay, next read the number. Okay, in this case, of course, we can directly initialize it to 3, because we have a separate step for dividing it by 2. So for apart from 2, whenever we want I value, that is where we will start with 3. Okay, so while n is divisible by 2, now how do you find out whether a given number is divisible by 2? Is nothing but you can use mod operation, which also has been discussed in various algorithms previously. Kindly go through those algorithms. So if I'm getting a 0 reminder when I'm dividing it by 2, it is understood that it is a even number. So if it is divisible, then what we are going to do is we are going to print the value 2 and divide by n. So let us do that. So n is 36. Repeat the following steps. So I'm going to print divided by 2. So 36, 1, 18 and then I'm going to print it once again. When I check, 18 is even. So 9 is 18. Once again, I'll print the value of 2. Next step, when I come, of course, the value of n has been now changed to 9. 9 is not an even number. Hence, I will come out of this loop and then I will enter step 5. All right. Now in step 5, after step 4, n must be odd. Yes, in our case, n is odd. Obviously, because if it is not divisible by 2, any number, it is not an even number. Hence, it has to be an odd number. And then I will initialize I by 3. Why 3 is because we have already discussed after 2, we will take the next prime number, which is 3. And then to the square root of n. This is our stopping criteria, where we will only go up till square root of 36 and repeat the following steps. While I divides n, okay, so does 3 divides n? Yes, it is dividing. Print I and divide n by I. So what I will do, I will divide 9 by 3 and then also I will print. So this is my output. Okay, so this is my output. Let me just rub this so that it is okay. So already we have divided 9. So the given number n twice, and then this is 2. We have divided twice. Next number we have divided is 3. Okay. After I fails, no, I do not fail. Once again, when I check, we can divide 3 once again, isn't it? So once more, I'm going to print 3. So these 2 steps we are going to repeat until I fails to divide n. So the moment I fails to divide n, of course, here when I come here, 3 does not divide 1, and then I'm going to increase the value of 5. So when I increase the value of 5, and we will continue. So as and when we will come here, now, of course, 5 also doesn't divide 3, and hence what will happen is we will reach the termination condition of the loop and we will exit from the loop. Okay. Then after that, we are checking if n is greater than 2. Now, why is this condition? This condition is mainly to avoid printing the numbers which are less than 2, because we do not want to print 1 as an output, because 1 is not considered as a prime number. Okay, so we want all the values which are not which are only prime numbers. That is the reason, and this is the output what we are going to get. Hence, I can write that prime factorization of 36 is 2 into 2 into 3 into 3. So this is what is the output is. All right. I hope this algorithm is clear. If you have any doubts, students, kindly write it in the comment box. I'll try to clarify it. So till then, keep learning. Thank you for watching.